Alright, so I accidentally did a tiny bit of work before. It was nothing at all. It's just I sort of took out, I noticed basically this is really just deriving the hypotenuse. So I took this out and put it here so that you can use it in other places when you want to derive the hypotenuse, when you have the other two sides of a right angle triangle. Yeah, that's my limit in terms of math. So, looking through his code program, Control X1, Control XB. Let's look through it. Hey, how come it indented? Oh, that's right. I re-indented it, and I unindented it when I maggot statused. Whoops. Region. Okay, there you go. Alright, so we pretty much know there. You know, first we're going through all rows, then we're saying, okay, set collision to null, because initially we have no collisions, right? Then we say position is equal to current bubble. No, I really don't like it when people, maybe it's just me because I'm dumb, but I really don't like it when people abbreviate things, honestly. Either make the variable one letter long or make it the full word. Don't, anyway, whatever. That's just, I mean, that's me being totally nitpicky, so. Position is equal to current bubble dot get sprite dot position. So that is the actual XY coordinates, evidently, or evidently left top coordinates of the sprite. So start is the bubble just offset a bit by its center of center point. So it's now the start is actually the center point of the circle. So that's effectively that's where the line is going to start. Dx is the math sine of the angle, dy is the negative math cosine of the angle. Why is it negative? I don't actually know. I wish there's a cool like online thing to play with sine and cosine and all that stuff, just so I could sort of get a sense. You know, maybe there is some sort of online thing. The sine, and that's not how you spell it, cosine and tangent of different angles. This is lame. Yeah, how come there's not like a visual thing I can just play with where I can spin it around, make different angles and say, yeah, this is what the sine, cosine, and tangent of that angle is. Just so I can get a feeling for it. Open up my Google.keep, which I'm opening in a different window, so you don't see all of my genius ideas. I'm joking. It's mostly just because, like, sometimes, for instance, when some of the things I keep in keep are people's names, right? And sometimes when I write down somebody's name, I will put something that's like a distinguishing feature, like large birthmark above eyebrow, you know. And I just don't want people to be offended or to have their feelings hurt, mostly, you know. Okay, so what was I going to say? Oh yeah. Website that lets me explore sine, cosine, and tangent. I draw measurements. Okay, cool. Oh, that's weird. Alright, anyway. Alright, so anyway, moving on. For some reason it takes the negative math cosine. I'm sure if I knew basic trigonometry or geometry or whatever, I'd know why that is, but I, at this point, do not even know. So anyway, then we're just going through every item in the row, and we're saying, given this row, okay, then we're going through every column in the row. So sorry, this is every row in the actual rows. This is every column in the row. We're looking at a bubble. We're asking, does the bubble exist? And that's because with his implementation, half of the spaces are null. They don't actually have bubbles in them. So that you can do that staggering thing easily. Var coordinates is equal to bubble.getCoordinates. Is that the same? Get coordinates equaled. Nope, that was position. What's the difference between the position and the coordinates? Oh dear. I don't know. It looks like they're both integers. I guess position is left and top, and coordinates is x and y. Nope. Coordinates is left and left as well. Hell, I don't know. Maybe it's just anyway. They both have. So you take the distance to the bubble, and the x direction is start.left minus coordinates.left, and the y direction is start.top minus coordinates.top. That makes sense. So this is just saying, effectively, this is the two parts of the right angle, right? The x and the y. The t, I guess, would be more like, let's just say it's like this: the x or the x and the y. The t can be derived by saying dx times dx. Where did we do that? We did that here. Oh, the sine, yeah. Sine times the distance to bubble of x. This, that, okay. Times the dy times the distance to the bubble. So yeah, the hypotenuse can be derived by just putting those together. The ex is equal to the negative t times the dy plus the start left. Oh shit. Okay. This is where we started. This is the negative t times the dx. So this is the rate of change, I guess, for x. This is the rate of change for y, right? Well, it's not the rate of change. This t actually is the distance from here to there, the hypotenuse. T is the distance. This is the magnitude of the hypotenuse. Ex is... Alright, wait a minute. What's the difference between ex and x? Oh, I see, yeah. Okay, yeah, ex is... X and y is just where is it? No, actually, this is a magnitude too. This is the x magnitude, and this is the y magnitude. From that, we derive this. This is a squared, this is b squared, and this is c squared t. No, it's not. This is just t. You know, it's really stupid, but I don't actually get what t is. What is t in this case? I'm going to read the actual sentence he has provided for us about what t is. Okay, so alright, dx and dy, I'm right about that. That is, finally dx and dy define how much a bubble moves left or right, dx, or up or down, dy, relative to the total distance the bubble will move. Okay, let those variables define. Alright, cool. Alright, so what is... so dx times t plus start . var t equals the, so here it is. This line tells us at what proportions of the fired bubble's total movement it will be closest to the candidate bubble center. From this, we can calculate the screen coordinates where this happens. Why is that true? Why does t tell us, to quote him again, why is this the line that tells us at what proportion of the fired bubble's total movement it will be closest to the candle's bubble center? Why is that true? Dx times distance to bubble x. Because we've drawn a point between the center of the circle and the starting point of the thing, and we have offset this value. This line tells us what portion of the fired bubble's total movement it will be closest to the candidate's bubble center. I don't really get why that's true. Math.sign. It's opposite. Oh wait, they switched the way they're doing things. Sorry. Next we'll calculate t at the closest point on this line to the center of the bubble that we're checking against. Next we'll calculate t, okay, at the closest point on this line, to the center of the bubble that we're checking against. Okay, I think I get that. This is the thing between us and the center of the bubble. I get that part. So this is of the line that we're drawing through the whole thing. Honestly, I actually just don't get why this works, what it's doing. The rate of change for the bubble on the x-coordinate times the actual distance to bubble x. Why would that give you the closest point, or the ratio at time t? Or why would the summation of these two things give you the t value? Why would that be? Where's where this happens? I don't get it actually. Dx times distance to bubble. Distance to bubble is just, it's the start left minus the coordinates left. So this is just it's saying, you know, the bubble, if the bubble's 0, 0, and this one's 0, and this one's 4, 5, it's going to say x is 4 and y is 5, you know? Okay. So yeah, I mean, we're just... t times dx plus stuff. I just don't quite get what this is, really. Dx plus start left. I'm gonna have to console log this some because I can't figure out what this is doing. You know, this is such a difficult problem to. There's so many things. Alright, screw it. Positive t times dx plus start left, negative t times dy plus start top. Okay, I think I get this. This is saying run it backwards because we're starting from the left and the top. So rather than doing positive t, do negative t. Basically, it's a subtractive method rather than an additive method of arriving at the same point. Distance EC is EX minus coordinates left times just squared, basically. EY coordinates top squared. Square root. So this is just actually the distance, or this is the Pythagorean formula. So square root of a squared plus b squared is the distance. Okay, so t is not the distance, whatever it is. Which we kind of knew. I knew it wasn't the distance, but I don't really get intuitively what this really is, what this represents. In fact, this one, we actually have something specifically for this, right? We can use this coordinate one, which will just take this apart. And we can put in x for the first one and y. It doesn't really matter which one you put in, what order you put them in, but alright, then we go on, we say, I'm unclear what is going on here, basically. Anyway, then we say distance EC. So we're saying, okay, given that we have a distance, what does EC stand for? I'm not sure. Is less than bubbleshoot.ui.bubbledims times 70.75. Okay, so that's just saying, you know, we've made it a little bit less than it needs to be. Instead of being 0.88, which is what it should be, 44 divided by 50, or 50 divided by 44. Yeah. We've instead made it 0.75 just so you can squeeze by bubbles rather than that you narrowly hit, you know. Math.square root. Same thing, this is a distance function. Dimensions times double dimensions, okay? And distance EC times distance EC. Okay. We calculate two offsets, t minus dt times dx, t minus negative t minus dt times dy. Wait. Offset 2 is t plus dt times dy, negative t plus dt times dy. Distance to collision 1 is this function 2 is again the Pythagorean stuff. A squared plus b squared is equal to c squared. Distance to collision 1. Alright, then we're just finding the actual shorter collision. Now we're picking one of these two. There's some sort of negative stuff that has to happen if we're in. Oh. Is this explained in the book? Not interesting. This really isn't helping me understand what this math is actually doing. Seems like it should be simpler than this. This just seems really complicated. I'm basically just asking, does a line intersect a circle function? I guess it is pretty complicated. Circle by okay. That makes sense to me, fine. See, why does this make sense to me? This doesn't make any sense. Distance to double. project a vector AC onto AB. Okay. The projected vector AD gives the new point D. So A. Okay. And I can do that because that's C squared plus AD squared is got to be equal to DC squared. Or AC squared is equal to AD squared. You know, I can then solve for DC squared. So I know what DC is, okay? If the distance between D and C is smaller than or equal to R, we have an intersection. That does seem a lot simpler. And I know how to go from... Okay, first of all, I know how I have a line, right? That's easy. I just cut two lines. Then I know, okay, I can take the line from A to C by just starting from the initial point and going to the center point of the circle, making a line that way. Then given that I have AC and that I also have, oh wait, actually there is a problem here. I don't know what AD is, do I? How do I know where D is? Project the vector AC onto AB. I don't know what that maybe means. The projected vector AD gives the new point D. I get the idea, I actually just don't know. Okay, so I know how to calculate. This is given, effectively. I know the starting point of the bubble. I know the direction the bubble's going, so I know the ending point, or the vector of the bubble. I can also say, okay, given the starting point of the bubble, what if the bubble is aimed directly at the circle? So that's, it's a line segment going like this. This is a line, and this is a line segment. Okay. Okay, so then I just need to calculate this. Alright, I'm beginning to think the only solution I have is to basically kind of verbatim copy this code, except do it in Clojure. So I'm going to try to do that. And there's only one way to test against that, since I have no real test here. So, ugh, sucks. Yeah, that is actually a problem. I really don't have any good way of testing this. since in order to actually, I guess I could run his code and just run the source. The problem with that is, let's just see. I'm not even sure I can. Let's see. So what I guess I should. Steven work. What are we looking for? We're looking for HTML5, ABCFG. Then we're gonna go book source, chapter. Let's just go to 7, index. Supposed to do something? Alright, maybe I need to actually host it on a. That's weird. Delivery source jQuery. Now it's trying to do a file. Lame. Okay, boring. Alright, let's just, I don't know, I don't feel like, I'm feeling demotivated because this is just, alright, so let's just do the whole thing. Alright. I really don't like code I don't understand at all. Okay, so, let's basically return if it intersects, what it intersects by, and if it doesn't intersect, we'll just return null, or nil, in this case. Alright. So what does it take? It takes a line, and takes a bubble. It takes a radius. Okay. So what's it going to do? It's going to say position current levels dot get sprite step position. Okay, so I can do that at least. Just copying what he does, basically. Okay. Yeah, sorry. Yeah, it just looks stupid anyway. That theoretically is our start. So we're going to calculate dx and dy from the angle. Oh, we do need angles in argument. So in closure, usually pass in the collection first, and then I guess less specific things second. I'm going to say dx is equal to math.sine of the angle. Okay. dy is equal to. There's no way I'm going to be able to copy this whole thing correctly. I'm going to have something wrong in here, and I'm not going to know what's wrong. Because I don't even understand what this code is doing at many points. This is a bind. Oh, sorry. Obviously, I paused the recording for a little while and just wrote this out myself. I didn't feel there's any real purpose in actually watching me type it out, because there's no point in watching somebody doing something that they don't understand themselves. And yeah, so honestly, I really don't get what the math is doing here. This is just confusing to me. So I try to basically look at what's on the left and build something that's identical on the right. That's really all there is to it. It's dense. It's unclear what's going on here. The only difference between behaviors is this one returns a single collision. It is the one collision that is the closest collision, while mine returns a sequence of collisions where basically each collision is returns all the collisions that you might have had as you travel through your path. Yeah. Other than that, conceptually, it's supposed to be this, or not conceptually, it is supposed to be the same algorithm, except mine returns a sequence of all the collisions that you had, and this one would just return, and the one to the left, the JavaScript one, just returns the most recent, or the closest collision. I'm sure there are errors here, right? Because I mean, it's hard to just, especially when you don't understand what's going on. I'm sure there are errors in my actual copy from left to right, but I attempt to do it as well as possible. I don't feel like testing it, honestly. I'm just going to actually get it to display on the screen, and then I'm going to figure out what's wrong based on the visual feedback I get on the screen. I gotta say, this is, in my personal opinion, I don't want to be critical, but this is, to me, the weakest point of the book, right, is this, because reading through his examples really doesn't help me understand what this is really doing, basically. And it's my fault in the sense that I do not remember geometry at all, in the least. And so all this is just like gobbledygook. I'm sort of first principle reasoning through it when I read it, basically, but having said that, the explanation of the book doesn't really help you understand what this is actually doing. It just, yeah. So anyway, this is me attempting to copy this code over here. I think, and I'm sure there are errors right now in here, but it's my attempt. I'll fix it up. I'll have to actually correct the errors at a later point, but because I'm tired of working on the math stuff, it's really boring to me, basically. Let's get on to more interesting events and stuff like that, and data structures, or just not even data structure, just how are we actually going to organize this program. So I'm just going to leave it as that. So I think math-wise, I've at least defined, if nothing else, I've named the two functions that need to exist, which is, the first function is just give me a function that will take a bubble through time, that'll tell me where a bubble needs to be at different points in time on that bubble's lifespan. And function number two is the collision sequence, which just takes all the bubbles that are static, basically, takes the bubble that is the fired bubble, and will hopefully, and takes the angle that the bubble is fired at, and should return a sequence of all these bubbles that would have been hit by this fired bubble. Ideally, at least, that would be what would happen. In reality, I am almost 100% certain there are errors in this code, yeah, that's about it. Anyway, a bit disappointing. It's a bit disappointing. I really don't like writing code that I don't understand. In my general opinion, if you can't understand the code you're writing, you're copying somebody else's code and you can't understand it, you shouldn't be writing it, basically. You should hand this off to somebody else, basically, or you should develop the chops necessary to actually understand what this is. Obviously, I'm not doing that this time. I'm just making best effort to copy it. I'm sure there's going to be problems. I'll have to figure them out. I don't know if even fixing all the problems and getting the code to be correct, I'm not sure I'll really understand what this is doing, really. That's disappointing, but you can't be an expert at everything. Anyhow, hope to get to more interesting things tomorrow. That's the end of this video, and that's the end of the math section of this. Talk to you later.